The air crackles with anticipation and a hint of fear. Thousands gather, phones raised, eyes fixed on a silent 20-story giant. This tower of concrete and steel has stood for decades, but today it's coming down, by design. Engineers have spent months planning this moment, calculating every angle and explosive charge. Suddenly, sharp cracks echo from the building's base. For a heartbeat, nothing happens. Then a ripple runs up its spine. The building hesitates, as if taking a final breath. With a deep groan, it begins to surrender, not toppling but folding in on itself, collapsing straight down. Floors pancake, dust billows, and the roar is deafening. A force of nature unleashed by human hands. In less than 20 seconds, it's over. Where a tower once stood, there's only rubble and dust. The crowd gasps, then cheers. They've witnessed the total deconstruction of a massive object with pinpoint precision. This is myth-busting science. With planning and explosive flair, even giants can be commanded to fall. It's a beautiful, messy, awe-inspiring display of engineering at its most dramatic. The spectacle is over, but the story of how it happened is just beginning. What does it take to bring down a skyscraper so perfectly? Let's break down the science behind the spectacle. Welcome to the world of controlled demolition. What are we really bringing down? Let's dissect the anatomy of a skyscraper. A 20-story building is a complex skeleton of steel and concrete designed to defy gravity. Its steel I-beams form a rigid frame distributing immense weight to the foundation. The central core housing elevators and stairs acts as the building's spine. Concrete floors stiffen the structure, preventing twists and turns. This isn't just a stack of blocks, it's a fortress built to withstand hurricanes, earthquakes, and its own crushing mass. The real challenge? The neighborhood. These giants are surrounded by other buildings, busy streets, and critical utilities. A mistake could be catastrophic, so the demolition must be vertical, falling neatly into its own footprint. Engineers study blueprints, test concrete, and scan for hidden weaknesses. They become biographers of the building, learning its secrets. To bring down a giant, you don't fight its strength, you exploit its weaknesses. It's a high-stakes puzzle with a thunderous solution, and every piece must fit perfectly. How do you make a skyscraper fold into a neat pile? It all starts with a plan. Controlled demolition is about triggering a precise, sequential failure, not chaos. Engineers identify key load-bearing columns, usually at the base and lower floors. These columns are pre-weakened. Steel beams are partially cut, concrete drilled for charges. The building must remain stable until demolition day, but weak enough to collapse on cue. The collapse is choreographed with millisecond timing. Charges on one side detonate just before the other, creating a controlled lean. This uses the building's own weight to pull it inward, away from neighbors. Every step is modeled on computers. Engineers run simulations to test explosive placement, timing, and debris spread. It's a digital dress rehearsal for a real-world performance. The plan is the demolition team's Bible, every detail calculated for safety and success. There's no room for improvisation. The margin for error? Zero. When the plan is perfect, the building will fall exactly as intended. That's the art and science of implosion. It's not just destruction, it's precision engineering. And it all happens in seconds. Now the fun part: explosives. Forget cartoon bombs. Real demolition uses RDX or PETN, stable yet incredibly powerful. Shaped charges focus explosive energy like a surgeon's scalpel, slicing through steel or concrete. Linear shaped charges with their V-groove create a jet of force that cuts cleanly. Charges are wrapped around columns or placed in drilled holes, severing supports instantly. Timing is everything. Detonators and millisecond delays choreograph the collapse. A 25 millisecond delay between rows can pull a building inward. Blasting technicians spend days wiring hundreds of charges, double-checking every connection. The difference between a beautiful collapse and disaster, placement and timing, its overwhelming force applied with watchmaker precision. This is demolition's true artistry. When the dust settles, the real work begins. Cleanup. The site is a mountain of rubble. Twisted steel, shattered concrete, tangled rebar. Massive hydraulic excavators equipped with shears and pulverizers cut and crush debris into manageable pieces. Materials are sorted. Steel for recycling, concrete for crushing into new construction aggregate. It's surprisingly sustainable. Most steel is reborn, concrete reused. Water cannons keep dust down, protecting workers and neighbors from harmful silica. Cleanup is slow, noisy, and dirty, but just as engineered as the implosion. Every step is planned for safety and efficiency. From chaos, order, and new beginnings emerge. The cycle of construction and deconstruction continues. Safety is the foundation of controlled demolition. Months before the blast, teams plan exclusion zones, coordinate with police and fire, and calculate safe perimeters. On demolition day, streets are blocked, security patrols the area, and the building is swept multiple times to ensure it's empty. The final countdown is a masterclass in precision. The blasting team checks every circuit, tests connections, and signals warnings with air horns. Only the lead blaster can arm the firing system. When every checkpoint gives the all-clear, the countdown begins. 5, 4, 3, 2, 1. A button is pressed, and the millisecond-timed ballet of explosions begins. In that instant, months of planning and safety checks come together. The building collapses exactly as intended. The crowd erupts, but for the team, it's validation of flawless execution. There's no room for error, only perfection. Every life depends on it. That's why safety is never an afterthought. It's the invisible force behind every successful implosion. Demolition has its legends, spectacular falls that made history. Seattle's Kingdom, a domed stadium, brought down in 16 seconds with 4,500 pounds of explosives. Fort Worth's Landmark Tower, a 30-story skyscraper with tricky X-bracing, imploded with surgical precision. Detroit's J.L. Hudson department store, the tallest building ever, imploded just feet from an elevated rail line, pulled away flawlessly. Istanbul's Tav Tower's two 22-story towers collapsed inward in perfect synchronization. Each demolition was a feat of planning, timing, and control. These weren't just destructions. They were milestones in engineering. Every famous fall pushed the boundaries of what's possible. They taught new lessons in safety, precision, and creativity. The world watched, and engineers delivered. These moments are more than spectacle. They're proof of what human ingenuity can achieve. The legends inspire the next generation of demolition experts, and the bar keeps rising. The future of demolition is digital, robotic, and smarter than ever. Drones now scan buildings in hours, creating detailed 3D models for engineers. These digital twins allow for hyper-accurate simulations and pinpoint planning. AI analyzes data, suggesting optimal charge placement and minimizing risk. Remote-controlled robots crawl into unstable buildings, drilling holes and placing charges, keeping humans safe. Even cleanup is evolving. Autonomous machines sort debris for recycling. Technology is making demolition safer, faster, and more sustainable. The dusty, brute force days are fading. Now it's a high-tech, precision-driven process. The future is here, and it's changing everything. Controlled demolition is engineering's grandest performance. It's the art of turning chaos into choreography, destruction into precision. Months of planning, seconds of spectacle, a testament to human ingenuity. Every implosion is a story of science, teamwork, and flawless execution. The next time you see a building fall, look for the hidden science and invisible safety net. Demolition isn't just about endings. It's about clearing the way for new beginnings. It's a dramatic, explosive, and brilliant field, where the thrill of destruction meets the genius of engineering. And honestly, what could be cooler than that?